Hello, and welcome to the Reactor Room, where we solve professional engineering problems in the chemical discipline. My name is Zachary Brownstein, and in this video we will solve the following problem. A chemical process separates a vapor-liquid mixture of N-butanol and water at 87 degrees Celsius. At the operating conditions of the separation process, N-butanol and water form an azeotropic mixture. The vapor pressure of N-butanol is given by the following Antoine equation. The activity coefficient of N-butanol in the azeotropic mixture is 1.6. The total pressure in atmospheres of the separation process is most nearly... Okay, so the first item that jumps out at me is that we have a binary component system of N-butanol and water, which comprise a vapor and liquid mixture. Additionally, we have an activity coefficient and asked to find the total pressure in atmospheres. This lets us know that we will be working with a vapor-liquid equilibrium. So let's find our equations. Well, we know that for each component I, we have the following vapor-liquid equilibrium equation. The fraction in the vapor phase times the total pressure is equal to the activity coefficient times the fraction in the liquid phase multiplied by the vapor pressure. Here we see that this is the vapor phase and this is the liquid phase. We're going to rearrange for the total pressure. That is what the question is asking. So we're just going to rearrange everything. Okay. We're also told that we have an azeotropic mixture. This means that the fractions in the liquid and vapor phase are equivalent for each component. Algebraically, this means that x equals y. So we can simplify our equation. Great. Well, we know the activity coefficient. Now we just need to find the vapor pressure. The problem gives us the Antoine equation for N-butanol. So let's see what units we have. Our temperature is in degrees Celsius and our vapor pressure is in millimeters of mercury. So knowing this, let's put everything in. And it should be noted that this is for N-butanol. Plugging this into our calculator, we get 2.3. Thus, in order to get the saturation pressure, we have to have both sides be used as exponents along with a base of 10. This is about 205 millimeters of mercury. The problem statement asks that we convert to atmospheres. So knowing that 760 millimeters of mercury is equal to 1 atmosphere, we just divide by 760. This gives us about 0.27 atmospheres. Now we have all the information we need. So let's solve for the total pressure. We have the activity coefficient value. We multiply by the vapor pressure. This gives us a total pressure of 0.43 atmospheres. Great. Going back to our problem, we see that this is A, which is the correct answer. Thank you, and good luck.